For Unit 2, Day 3, we're going to talk about biconditional statements and how to recognize something's a good definition. So again, I have scanned in the Day 3 and the Day 4 notes, so you could just see the writing if that's easier to view than the video. So all of this has already been scanned in and it's on Google Classroom for you. But I do want to walk through like what some of this stuff means. So first, biconditional. What is it? So a single true statement that combines a true conditional statement and its true converse. So if you were to write an if-then statement and the converse statement was true, they're both true, then it's a biconditional statement. And you would read this like in symbolic form. You would say P, and then you would have this arrow like this. Looks kind of like how we do a line, and then Q. And this part right here is like represented as if and only if. So it's read as P, if and only if, Q. And every biconditional statement has the phrase if and only if. If a sentence does not have that phrase, it is not biconditional. It has to have that phrase. Okay. So, for example, it says, what is the converse of the following true conditional statement? So, if the sum of the measures of two angles is 180, then the two angles are supplementary. So, this conditional is P implies Q. Okay? And last class, or last time you guys watched videos, you had that little orange card. Okay? So if I look at that orange card, if I look at conditional, P implies Q, the converse is just flipping the Q and the P. So now I'm going to say if the two angles are supplementary, then the sum of the measures of two angles is 180. I'm just flipping these around. Okay? So I'm going to go ahead and jot that down. If the two angles are supplementary, then the sum of the measures, then the sum of the measure of two angles is 180. So I want to know, is that converse true? If the two angles are supplementary, then the sum of the measure of the two angles is 180 degrees. Yes, that is true. Okay. So yes. Yay. Okay, so since the conditional and the converse are both true, we can write the statement as a biconditional statement. So we could use that phrase if and only if. So here's how I would put together. I would say two angles are supplementary if and only if the sum of the measures of the two angles is 180 degrees. Okay, totally shorthanded it right there. Okay. Then it says, for example 2, what are the two conditional statements that form this biconditional? So we want to know what's the conditional and what's the converse of this if and only if statement. So a ray is an angle bisector if and only if it divides an angle into two congruent angles. So I'm going to break it up. I'm going to say that the P, this part right here, a ray is an angle bisector. So this is my P. Okay? So you can see I highlighted my P's. And then my Q is it divides an angle into two congruent angles. So this is my Q. Alright, so now I need to take this and write it as an if-then. So for the if-then conditional, I'm going to say if this right here. If a ray is an angle bisector, then my Q, it divides an angle into two congruent angles. Okay. Now, so I'm going to move this just a tiny bit. Okay. For the converse, I'm just taking my P and my Q and I'm flipping it around. So now I'm going to say if it divides an angle into two congruent angles, then a ray is an angle bisector. But it doesn't make much sense if I use that pronoun first, it. So what I'm going to do is I'm going to say if a ray divides, because it's referring to the ray that divides it is an angle bisector, an angle into two congruent angles, then it is an angle bisector.